My name's Chris Carlson. Our last session today, we're going to talk about secure remote access solutions. I'm in the tech group at Logic and do networking stuff and Wonderware stuff. I thought we'd frame the discussion around 5 different applications. So these are some common remote access type applications. This is the device we're going to be talking about, kind of little network diagram going on there. Very common one is I need to do remote troubleshooting. I need to get into a network and do some PLC programming remotely, look at diagnostics on drives. Very typical. This connection doesn't need to be on all the time. It does need to be very easy to set up. We don't want to have somebody change a configuration or move a cable on a device to allow us in remotely. Typically, we're coming in over the internet from a laptop, some portable device, and the need to access multiple devices on the network. So remote configuration and troubleshooting. Remote operation is very similar, except typically we want to limit the operator, somebody who's going to operate this thing remotely, to not all of the devices on the network. Maybe just a Wonderware computer, terminal server type thing, some other HMI, but very similar to the remote troubleshooting. This is kind of an interesting one. No remote access at all, but let's say I have an on-site contractor that I need to allow access to my network. They need to do some PLC programming, but I don't want them to have access to other parts of my network. How would I accomplish that? It's another application we'll talk about. Typically, you'll do it on like a time-based method. I need to have this contractor on site. I only want them access to certain devices, and I only want to give them access for a day, a week, a month. Another application is site-to-site VPN, or virtual private network. Here we're using the internet to make these 3 remote sites seem as if they're connected with an always-on network. So kind of different than the previous applications, this one is always on. Those tunnels need to be established automatically, so the virtual private network tunnels, if you will, the connections between the 3 sites, those are created through the internet. We're connecting to the internet for those, but they need to be always on, and they need to be able to come up automatically. So if our internet service provider drops a connection, we don't want to have an operator or a technician go push a button, move a cable to get those things to establish back automatically. Examples of these would be like in Wonderware system platform, node-to-node communications from remote sites, or I'm pushing data from a Tier 1 historian up to a Tier 2 historian over a VPN connection, common application for those. And finally, we'll talk about kind of a generic remote networking piece, and that's optimizing traffic. So, example, I've got some Ethernet radios, I've got an Ethernet master radio. How do I make communications optimized on that network, on my radio network? We'll talk about 2 product lines that Logic has. The first one is Secomea. This is a new product line for us. Many of you may have stopped by and saw the booth out there. The other one is Moxa. That's our networking product line, which we've had for quite a while. We're going to talk about a specific solution there. We'll talk about the Secomea first. 4 pieces to the Secomea solution. The first one is the Site Manager. So the Site Manager is the one that sits inside the customer's network. Little black box. I've got one floating around here somewhere. I think it's on the back table back there. It sits within the on-site network, and it establishes the connection to a cloud service called the Gate Manager, which we're going to look at in a slide or 2. This controls access to the internal hosts or the internal devices in the network, so my PLCs, my Wonderware machines, whatever I need to connect to. agents, in Secomea terminology, you'll hear me mention the term agents. Those are just the devices internally that we're going to access from the outside world. Third piece to the puzzle is the gate manager. So this is a cloud service that the site manager connects to, and then remote users connect to the gate manager. The nice thing about this setup is it's very firewall friendly for IT folks. The connection is established internally. They don't have to open a port on the outside firewall to the corporate network. The gate manager is where you do your access permissions. So if you're an administrator, you purchase one of these, purchase the Secomea solution. Somebody in your organization becomes the administrator. You can go in and establish different roles, different users, and control which devices they can access on the internal network. That's done through the Gate Manager cloud service. Two-factor authentication, again, manages the connections to those internal site managers. Here's a little screenshot just to kind of give you an idea of what it looks like. Different devices shown in there. I can have different users and give them permissions. Very granular permissions to only allow certain people access to certain devices. Fourth piece is the link manager. This is the piece of software that the remote user uses to connect. So link manager running on a laptop is going to make whatever software you're running appear local to the internal devices. So a good example is, got a GE PLC over there. You can run Machine Edition on this laptop and it is going to connect as if it's local. Once that link manager establishes that that VPN tunnel into the site manager at the local site. There is also a link manager mobile. Similar to the link manager, it's a piece of software that the end user uses, but this is for web access, RDP, or VNC, so remote desktop or the VNC protocol only. You could run it on a computer, but typically people run it on an iPad or an iPhone. So it's used to connect to the internal network from the outside with an iPad or an iPhone. And that's why it's limited to those protocols. I don't foresee GE ever making Machine Edition to run on an iPad, so that's why you couldn't run Machine Edition on it. So here I've got 3 users, and I can establish permissions so that, let's say that top user needs access to all the devices in the internal network. I can create this user such that they can only get to the PLC, and this user could only get to the computer up there if it's a Wonderware computer and they need to do some Wonderware programming. The nice thing about this setup, this user doesn't even see those other devices that they're available. When you set up the permissions in the Gate Manager, those other two, the VFD and the PLC, will be completely invisible to that user. They don't even know they're there. Some other architectures. Site Manager has a serial connection, so you can connect a serial device. Has some hardwired I/O, so think of a machine that has an e-stop. When I hit that e-stop, I want to make sure that I sever any remote connection. I don't want anybody remotely connecting and turning on a machine, so I've got an input to accomplish that. I can also light a light that tells me when somebody's remotely connected. There is a Wi-Fi uplink port, so I can have a wired and a backup Wi-Fi uplink connection to the outside network. There is an option for a Wi-Fi connection from the inside side, if you will, from the agents. I can connect those Wi-Fi as well. There is also a cellular option, so for remote sites, no hardwired connection to the internet, cellular uplink. Secomea also makes an embedded version. This is something that you can embed in your own product. GE has done it with a version of the Quick Panel Plus. So there's a version that you can buy that actually has one of these Secomea site managers in it. So not only is it an HMI, a flat panel HMI, but it can also be used to manage those remote connections. So for the application where I have internal access, no connection to the internet, I don't want anybody coming in from the outside, Secomea has a hardware-based gate manager. So I've got a site manager in my network, or multiple, but now I can have a gate manager that would mount in my rack, in my data center, in my computer room. And this would function just like the cloud service, only it's all internal. So you can control contractor access inside, just like you could if you were using the service. You can also use it to manage external connections. It functions just like the gate manager cloud service would, only it's on premises. It's hosted internally. Shown as the hardware version here, that's something you'd mount in a rack. They also have a virtual machine instance. So if you don't want hardware, but you're running VMware, vSphere, you can purchase an instance that will run on an ESXi host instead of having the hardware. A little bit less expensive than the hardware since they don't have to supply the metal box and boards and stuff. In the gate manager, really good audit trails, so you get good record of who's accessed what devices at what times. There's email alerts, so the administrator could get emails when somebody's trying to access and set things up like that. Good time-based controls, so maybe I want to give a user temporary access for just today. I want them to go in and do some troubleshooting, and then I don't want them in there anymore. There's no, you don't have to ask them for a license back or a dongle or anything like that. The time-based controls you set up will control when they can get in. So of those 5 applications we started off at the beginning, where Secomea really shines are kind of those first 3. The remote configuration and troubleshooting is very easy. Very easy for that external user to connect and do work on that internal network. Very easy to set up the secure connection. Good for remote operation, real good for controlling internal access. So let's talk about the second hardware from Logic, and this is the Moxa secure router. Moxa has 3 different products in this line. We're going to talk about specifically the EDR 810 today. It happens to be the least expensive of the 3. I really like it because it's a very versatile switch, very versatile device. So recall our network diagram. It essentially takes the place of 2 devices. So we've got an external router and then just a regular switch. Right out of the box, it functions just like a managed switch. If you don't do any configuration on it, you can plug devices into it and they will communicate, just as if you pulled a switch out of the box. For the remote configuration and troubleshooting application, again, you can establish a VPN tunnel to the device. No cloud service involved. 2 different types of VPNs, and I won't get into the 3-letter acronyms that networking is filled with, but an IPsec VPN it supports, and an Open VPN, so an SSL or TLS-based VPN. That's what we're used to in our browsers when we go buy stuff off Amazon. That's a TLS type connection. The IPsec is built into Windows. That's the built-in Windows client that you can create and connect to it. It has a built-in firewall, so you use the firewall to control what devices you want to connect to on the internal network. And it still has all the features of a managed switch. Remote operation, again, very similar. I use the internal firewall to control where I want that external user to have access to. In Secomea, we didn't cover this solution. This is a really good application for the EDR. It can establish those IPsec tunnels automatically. So once you get these configured to talk to each other, get the permissions set up correctly, these connections come on automatically. If your ISP drops a connection for some reason, they'll automatically reconnect and make those networks appear as if they're connected together. Optimizing traffic, kind of a little bit more networking generic ways to take advantage of it remotely. So again, here we've got our Ethernet radios. We've got a master radio talking to some remotes. And typically, a lot of times what we see in the tech group at Logic, kind of a class of case where my DA server is slow, right? DA server is the piece of software that Wonderware or InTouch uses to talk to PLCs. My DA server is slow. Oftentimes we're looking at an architecture like this, and if there's no segmentation of traffic, you'll get the Windows broadcast traffic all hitting that radio network, and your radio network gets saturated with a bunch of traffic that has nothing to do with the PLCs. One of the things that you can do with the EDR is filter that traffic. So now I can, with the firewall rules, I can cut back on the amount of devices that can talk to the PLCs, and I can block some of that unwanted traffic off my radio network. Another thing that I can do with the EDR 810 is I can establish VLANs, or virtual local area networks. So, for example, I've got my control system network here. I've also got an accounting group of computers. I don't want the accountants getting on my controls network. So I can set up VLANs that will segment that traffic. It's a configuration that you do in the switch. So I get that traffic segregated. It isolates broadcasts, so any broadcast on the accounting network won't be seen by the control system network, and vice versa. It'll look like there's two physical switches there. But what happens if the accounting guys actually need a little bit of data from our control system? So again, here's our control system network, control system VLAN. Here's our accountants. Now, the EDR can act as a layer 3 switch. What that means, I can set up rules that allow certain traffic between those VLANs. So again, I'm still isolating, I'm still segregating traffic, I'm still isolating broadcasts between the accountants and the control system, but now I set up selected rules that let, for example, just historian data. Maybe the accounting guys need to access my Wonderware historian to get a little bit of data for billing or cost center stuff, whatever. I can allow just that traffic between those VLANs. So I still keep all their Windows stuff off my PLC network, but I let them have just my historian traffic across that boundary. So the previous solution is good if in your plant network you can set up VLANs and subnets. Sometimes that's not possible. Maybe your network kind of started a long time ago and it's grown organically. It's a very flat network, one big subnet, and with downtime and cost to change that, it'd just be too big of a hurdle, not feasible. So again, I've still got my two different networks, only now I can sprinkle these EDR 810s throughout the network, and they can act as a transparent firewall. So now we're not doing any routing between VLANs, no VLANs really, but the EDR 810 can function as a port-based firewall. So now out here in my control panels, I can say, you know what, keep all the traffic away unless it's from a DA server or my machine edition programming laptop or laptops or other PLCs. So even if I have a flat, not segmented, not very well segmented, no VLANs, I can still get that traffic optimization with the EDR. So it's a nice generic device to use. Got a lot of different applications. It will do network address translation. So what network address translation is, say I've got a machine that I purchased from an OEM and they built it with those IP addresses on their devices, on their machine. That's great, I like it. A couple years I buy another one, they build it identically to the first one with the same IP addresses. Can't have duplicate IP addresses on a network. I can put an EDR 810 in there and perform network address translation. So on the outside, I translate the .1 address to the .3, the .2 to the .4. Now I can put that on my network. And I could still do firewall things in here if I needed to. If I needed to keep Windows traffic off of it or other devices. So network address translation. Some other miscellaneous things. Again, I said the EDR 810 is a good generic device. It will do deep packet inspection on Modbus. If you have Modbus applications, what deep packet inspection is, for example, I can allow Modbus reads, so holding register reads, coil reads, but I could block writes, coil writes and register writes. So it'll do deep packet inspection on the Modbus protocol. It'll do different types of network address translation, logs firewall events, so I can see when somebody's trying to hit that and whether they're hitting a block rule or an allow rule, so I can see what's going on the firewall. It can participate in Turbo Ring, which is Moxa's high-speed, fault-tolerant ring, so you can have it participate in a ring if you have one of those. It will also perform IGMP snooping. Basically, that's a function that's used in a multicast network. So what's a multicast network? Allen Bradley, Ethernet IP, portions of that are multicast. So that's why that's important in our world, because if we have Allen Bradley PLCs, you're going to want to have that on the network. So, which one do I choose? Where would I use these? This is kind of how it breaks down for me. If primarily I'm doing remote configuration and troubleshooting, I need to just get in from an outside network to do some programming or some maintenance. Secomea is a great solution. Moxa works, it works well. The Secomea is easier. Same for remote operation. Controlling internal access, the Moxa cost-wise is less expensive, so it's a good solution for that. And of course, the site-to-site and optimizing network communications, because the EDR is more of a generic device, it fits those applications very well. The Secomea solution, there is the cloud service unless you do the internally hosted one, so if that's an issue for you, the EDR might be the better choice as well. So thanks everybody for coming.